Hello, so in this video I'm going to look at graphing a complex cotangent trigonometric function, and I'm going to do this by hand and then by calculator. All right. So again, we always start with the basic shape because we're really trying not to plot many points at all. So if you recall, going back to basics, cotangent of an angle is defined as x over y. So the input to a trig function is always an angle, and the output is some kind of ratio. And in cotangent, it's x over y. So because there's a variable in the denominator, that gives rise to moments when there are asymptotes, in particular when the denominator is 0. So when is it that y, which is this kind of motion on the unit circle, when is it that it's 0? There's just none. So that's at 0 and pi. So we know at 0 and pi we have asymptotes. So I have here 0, x equals 0, x equals pi. And in fact, this is just one graph. If I kept going, it's multiples of pi, right? So it's then 2 pi, 3 pi, and then negative pi, and so on and so forth. But then I'd like to have a few other what I call anchor points, just so I know, okay, what would the value be? So I memorized then here at pi over 4, pi over 2, and 3 pi over 4, because they're kind of nice whole numbers. At pi over 4, the x-coordinate is square root 2 over 2, and the y-coordinate is square root 2 over 2. So when I take the cotangent of pi over 4, I get x over y, and I get 1 as a ratio. At pi over 2, x is 0, y is 1, so 0 over 1 is 0. So the cotangent of pi over 2 is 0. We can write that out here. Okay. And then the cotangent of 3 pi over 4 is, again, the x over y, where these are the coordinates, and you'll get negative 1. So when you put all that together and you graph them, this is the basic shape you get. And here's my anchor values that I'm looking for. I'm looking for 0, pi over 4, pi over 2, 3 pi over 4, and pi. All right. So to graph this more complicated equation then, I'm going to set this, what's here in the input of the argument, equal to these x values so that I know what x would make it end up taking the cotangent of these values. So here you go. I've gone ahead and set 3x plus pi over 2, right? That's what's in here, to the anchor values I want. 0, pi over 4, pi over 2, 3 pi over 4, and pi. And therefore, when I get, for example, negative pi over 6, I know that's where I'm going to have an asymptote. When I put in negative pi over 12, I'm going to end up taking the cotangent of pi over 4, right? So here's an example. When I put in x negative pi over 12, I'm going to be taking the cotangent of pi over 4. So what that means is all of this becomes cotangent pi over 4, which I know is 1. And I know that because, again, this is that basic information that I have already memorized. Cotangent of pi over 4 is 1. And so then I have negative 5 times 1 is negative 5, minus 2 is negative 7. So the point I'll be plotting is this x value, negative pi over 12, and this y value, negative 7. Okay? And then I went ahead and did the other ones for you. So if when x is 0, right, then it acts, so I end up taking, the whole reason I solved for this x value is so that I'll end up taking the cotangent of pi over 2, right here. And so then I basically know that the cotangent of pi over 2 is 0, so negative 5 times 0 is 0, minus 2 is negative 2. So I'm going to plot the point 0, negative 2. And then finally at x equal to pi over 12, I know I'm going to, because I solved for it, I know that when I put in pi over 12 here into the x, I'm going to end up finding the cotangent of 3 pi over 4. So when I take the cotangent of 3 pi over 4, I have negative 5 times negative 1 minus 2, so that's positive 5 minus 2 is 3, and I'm going to plot the point pi over 12, 3. So here I am putting it all together, right, where x is negative pi over 6 and positive pi over 6 are the asymptotes. So here are my asymptotes, and then I plotted those values, those points that I talked about, and then connected them. That's the cotangent graph that I get. Now, I want to go ahead and also do this on a calculator, so on your TI, and one of the things I always mention is please do make sure you're in radian mode. Right? So you want to make sure you go to mode and that you're in radian mode. Okay. Then what you want to do is you want to go to y equals, and let's look back at that equation. Okay. And what I want to enter is -5, but remember this negative sign is not the operator, it's the fact that you have a number that is negative. So -5, right in there. And then I want to open a parentheses because I want to say times all this stuff. So I have parentheses. And because we're talking about cotangent is reciprocal of tangent, all I have are the 3 buttons, sine, cosine, and tangent. I want to say 1 divided by tangent. So I want to say here 1 divided by tangent. Okay. And now I want to put in that argument, 3x plus pi over 2 right here. So I'm going to have 3. Here's my x there. And then plus, and then here's my pi. So I do second pi divided by 2. So 3x plus pi over 2. Okay. And I'm going to close the parentheses, right? But remember, this parentheses closes the 3x plus pi over 2, and I need this parentheses to close that. So I'm going to have 2 parentheses here. And then finally the -2, right? The -2. So there it is. It's finally in there. And if I want to look at it, I can do zoom 7. It's going to take a little while for it to plot all of it because I'm asking the calculator to do this automatically, right? So it's just plotting everything in there. But what I might want to look at after this is done is say, hey, maybe I want to zoom in on that a little bit more and change the windows, right? So you can change the windows if you want. And what I would say is here the period is end minus beginning, right? So pi over 6 minus a negative pi over 6, right? So the period is pi over 6 minus a negative pi over 6, right? Is 2 pi over 6. So that's pi over 3. So you know that it's not a very large period. So maybe you want to go back a little more than negative pi over 6 and forward a little more than pi over 6. I might do pi over 4 just so you can see it. So let me kind of zoom in on this more, and I'm going to go negative pi divided by 4 to positive pi divided by 4, right? And now let's graph it. And it does take it a little bit of time to do its thing, right? There it is. There it is. And notice it's going through 0, -2, which is what we got when we did it by hand, right? 0, -2. But let's just check some of these values. Let's say I try pi over 12. I should get 3. So if I'm right, that'll happen. So I'm going to look at calc. So I'm going to do second, calc, and I'm going to choose 1, which is value. And I'm going to put in pi over 12. So I'm going to do second to get the pi divided by 12. And I know I should get what? 3. Okay? So you could play with this a little bit. Thank you so much for listening.